I am going to talk about one of the most famous cipher machines of all time. It is a code machine called the Enigma machine, used by the Nazi Germany in World War II to send secret coded messages. Here is the picture of the Enigma machine, you can see it. Arthur Scherbius, a German engineer, developed the machine concerned which is capable of transcribing coded information in the hope of interesting commercial companies in secure communications. And here is the picture of Arthur Scherbius. You can see it. In 1923, he set up his Cipher Machines Corporation in Berlin to manufacture his product. Within 3 years, the German Navy was producing its own version, followed by the Army in 1928 and the Air Force in 1933. Now, I'm going to further analyze the Enigma machine by making a real-life demonstration. Due to the fact that I do not have an Enigma machine, I'm going to use a message that was sent by an Enigma machine in the past. The message concerned was number file. So, you can see the message here. The Enigma machine converted this message into a coded text, which reads as Y T H M Y I U R F G W. Notice here we had Y turn up twice. Here is the first Y and here is the second Y. And they turned up for two different letters. So N became Y and then later on E became Y. That's unusual. The other unusual thing you may notice is that the two E's in number file, so the first E is here and the second E is here, have turned into two different letters. So here E became Y, but the second E became W. Now, this is why the Germans thought they had an unbreakable code. Old-fashioned codes in the past, pen and paper codes that they used to use, if you had the same letter, it would become the same letter in the code. Enigma is different. Probably each time you did it, you would get a completely different code. So, let me explain you how this machine works. So, we have three things here at the top. Let me show you the original picture. As you can see, there are three circular things. Now I'm going to show you a magnified image of this. Here you can see it, the three circular things. These things are called rotors. And inside those rotors, try and imagine lots of wiring, and it's all crisscrossed wiring as well. Now, if I press a letter in the Enigma machine, the rotors move. In order to show the movement, I'm going to show you now a better picture representing the rotors. Here it is. When the first rotor does a full turn, it will kick the next rotor one place, and then the right hand rotor keeps going. Eventually, the middle rotor does a full turn and it will kick the left hand rotor one place. So, a fast, a middle, and a slow rotor. Imagine it like it is hands on a clock, like you have got a minute hand, an hour hand, and a second hand. That is the idea. Brilliant machine, though this is all it is, really, is just a circuit. The clever bit is the wires of the circuit are inside these rotors. So, when the wires turn, the battery will connect to a different bulb representing a different letter. That is why the letters change each time, because it has moving parts inside. Otherwise, it is just a simple circuit. each water has 26 different starting places. In fact, these waters come out and swap over. In fact, again, they had 5 rotors to pick from. They had a box of 5 rotors. You would pick 3 from a box of 5. And already we've got thousands of settings, and each one will produce a different code. So we are going to work out these combinations. Let me get a paper. So the first thing I said was we pick 3 rotors from a box of 5. In the first slot, you would have 5 rotors to pick from. Once you have picked that, in the second place, you would have 4 rotors to pick from. And in the final place, the third place, you would have 3 rotors left. And you multiply those numbers together. So it is 5 times 4 times 3. So there are 60 ways that you can put in 3 rotors from a choice of 5. Let me put it. Yes. Moreover, we have 26 starting positions. For each rotor, so we have 26 choices for the first one, 26 choices for the second one, and 26 choices for the third one. If you do that, you get 26 cubed, which is 17,576. 17,576. And it gets worse, because the military, the army, air force and the navy had something extra. They had this thing at the front of the machine. Now, as you can see, this weird thing, it has lots of wires in it. Now, this is called a plug board, and it is like an old-fashioned telephone switchboard, like an old patch board. We have 10 of these wires that you can see here, and each of these wires connect 2 letters into a pair. 2 letters in a pair will swap over. So if A is connected to B, then A and B would swap over. That is an extra level of scrambling only available to the military. Now, this had the most number of combinations. This calculation is going to be the hardest calculation. Now, I'm going to show these were our old calculations. I'm going to put our last calculation in here as the third one. So, there are 26 letters in the alphabet. How many ways to arrange 26 letters? Well, it is 26 times, 25 times, 24, all the way down to 1. That is 26 factorial. However, we don't want every combination of 26 letters. We only want to make 10 pairs. So that means there are 6 letters left over, which we don't care about. Because we don't care about them, that means we are allowed to divide. And we are going to divide by 6 factorial. Here is the process so far. Now, there are 10 pairs. We don't care what order those 10 pairs are in, because we don't care about it. We can divide by 10 factorial. And the last thing, to divide by 2 letters in a pair. If I swap them over, that would still be the same pair. If I had A and B, that is the same as B and A. That is still the same pair. So I can divide by 2, and I do that for each pair. There are 10 pairs, So I'm going to divide by 2 10 times. Just 2 to power 10. And that is how many ways that you can connect 20 letters into 10 pairs on the front of the machine. This. How big is that number? Let's calculate it. 150 trillion 738 billion 274 million 938,250. So let's now calculate this number. Let's multiply this number and the other ones so we can find the total. The total is 158 quintillion 962 quadrillion 555 trillion 217 billion 826 million 360,000 flat. That is the total number of ways that you can set the Enigma machine. Thanks for watching. Here are the resources that I benefited while making this video. Here are the resources. You can see them here. Thanks for watching and have a good day.